Hello, welcome to today's class. So this would be our first class on uninformed search, and in today's class we will talk about breadth first search, and this would be our first class on this topic. Um, Before we go to BFS, let me tell you what is uninformed search. So uninformed search are those search strategies that have no additional information about states beyond that provided in the problem definition. And as opposed to uninformed search, we have informed search, and another name for it is heuristic search. And in case of informed search, the search strategies know whether one non-goal state is more promising than another. This definition will be more clear as I proceed to explain BFS. And in uninformed search, we have different kind of search algorithms. Like we have BFS, we have uniform cost search, we have depth first search, then we have depth limited search, then we have iterative depending DFS, and then we have bidirectional search. In our next few class, we will talk about all these different search algorithms. In today's class, we will talk about BFS. And in case of BFS, it's a simple strategy in which the root node is expanded first, and then all the successor of the root node are expanded, and after that all the successor of the successors of the root node are expanded, and we go in that way. So in general, all the nodes are expanded at a given depth in the search tree before any nodes in the next level are expanded. Again, this will be more clear as I explain using an example. And the example we will take is the route finding problem, where we need to find a route from Arad to Bucharest. Now we will have the problem description, the problem formulation for this problem, and that problem formulation will be provided as input to BFS algorithm. And in the problem formulation, it will be mentioned that the initial state for our problem is Arad. Now what BFS do is, BFS is actually a modification of the graph search algorithm that we had discussed in the previous class. And we saw that in a graph search algorithm, we maintain a frontier list, and we also maintain an explored set list. So we maintain these two sets, if you remember from the previous class. Now in BFS, this frontier list is actually a FIFO queue. So it's a first in first out queue. So at the very start of the BFS, we will create a node from the initial state of the problem. The initial state of the problem is that we are in Arad. So our root node, our first node that we create is Arad, and we put Arad in our frontier list. So frontier list contains those nodes which has been generated so far, but they have not been explored yet. So that is the frontier list. So the Arad node, we have created a node, we have generated a node for Arad, but we have not expanded it yet. So it will be in the frontier list. Now what BFS do is that it does now have to select a node that needs to be expanded. And since the frontier list is a FIFO queue, the node that is in the front of the list will be selected for expansion. In this case, we have only one node, Arad. So Arad will be selected for expansion. And as we select Arad for expansion, it will be removed from the frontier list and it will be put into the explored set. And from the problem formulation, from the problem description, we know that the valid actions for this state, for Arad state, the valid actions are that we can go to Gerund, or we can go to Timisoara, or we can go to Sibiu. And we can now perform these actions, and when we perform these actions, a node will be created for Gerund, one node will be created for Timisoara, and one node will be created for Sibiu. And these three nodes, they have been generated, but they have not been expanded yet, so they will be put into the frontier list. So this is how the search tree looks at this point of time. And now the BFS algorithm, it needs to select which is the next node to expand. Now there is nothing in the problem description which can guide the BFS algorithm to select one of these three nodes. So there is no such information in the problem description which will tell the BFS algorithm that you need to select Sibiu first, because that point is not there, that information is not there in the problem description. If you look at the map of the map that has been given in an earlier slide, maybe visiting Sibiu would be the better option, because that action is which will lead us to Bucharest later. But as far as the BFS algorithm is concerned, it doesn't know which is the best node that should be selected next. And you know, BFS is an uninformed search, it's a blind search, so there is it doesn't have any information which will tell that one node is better than the other. So all these three nodes are equally important to be considered next as far as BFS is concerned. And so when we now need to select the next node, and you remember BFS use a FIFO queue, so whatever is there at the front of the list, which in this case now is Gerund, so Gerund will be selected for expansion next, because how BFS select the next node for expansion is by looking at this frontier list, and since frontier list is a FIFO queue, first in first out, and at the very start of the list we have Gerund, so Gerund will be removed for expansion next. So as we select Gerund for expansion next, it is removed from the frontier list and it is put into the explored set. So the red color means that node has already been explored, and now the frontier list has Timisoara and Sibiu. So we have now selected Gerund for expansion, and from the problem description we know that the valid actions in this state are, we can go to Arad or we can go to Oradia. Now if you remember the graph search algorithm from the last class, in the graph search we will not generate a node for Arad. Although we have a action go Arad, from Gerund we will not generate a node for Arad, because Arad is already present in the explored set. So any node that is present in the explored set or in the frontier list, those nodes will not be added to the tree. If we do add them, then we may get into a situation where we will go from Arad to Jerind, then from Jerind we'll again go to Arad, and from Arad again we'll go to Jerind, and we'll continue like this infinitely. So that would be a problem for the algorithm, as it will not stop. So where we allow repeated node, that was tree search, and when we disallow the repeated nodes, that is graph search. And how we disallow repeated nodes is by, whenever we want to generate a node, we first check whether it is present in the frontier list or in the explored set, and only if it is not present in these two lists, then only we will generate a node for that. So here for the action go Arad, we will not generate any node. However, Oradia is not present in the frontier list or in the explored list, so a node will be generated for Oradia. And now Oradia is added to the frontier list, and as you can see, it is added at the end of the list because this is a FIFO queue. And this is what we have at this moment. So expansion of Jerind is complete, and now we need to select the next node for expansion. And how BFS selects the next node for expansion is by looking at the front of the frontier list, and at the front of the frontier list we have Timisoara. So Timisoara will be selected next for expansion, and hence Timisoara is removed from the frontier list and it is put into the explored set. So at this moment in the frontier list we have Sibiu and Oradia, and in the explored set we have these three nodes. And now for Timisoara, if we look into the problem description, into the problem formulation, we will see that the valid actions in this state are go to Arad or go to Lugos. And as I had already explained, no node will be generated for this action go Arad. It will not be added to the, it may be generated, but it will not be added to the search tree. So for this action, no node will be added, but however for the action go to Lugos, a new node will be added, and this new node is now part of the frontier list. It is added at the end of the frontier list, and that completes the expansion of this node Timisoara. And we now need to select the next node for expansion, and since this is a BFS algorithm, BFS will select from the front of the frontier list, and at the front of the frontier list we have Sibiu. So Sibiu will be selected next for expansion, and hence Sibiu is removed from the frontier list and it is put into the explored set. And now for Sibiu, these are the 4 valid actions, and for the first 2 actions go Arad, Arad is already present in the explored set, so we will not add a node for this action go Arad. What about go Oradia? Oradia is not present in the explored set, but it is present in the frontier list. Hence, the node for Oradia will also not be added. So for the first 2 actions, no nodes will be added, because otherwise that would be a repeated node. However, for the next 2 actions, go to Rimniku and for go to Fagaras, those 2 nodes are not present in the explored set or in the frontier list, so the nodes for these 2 actions will be added, and these 2 nodes will also be added to the frontier list at the end of the frontier list. And our frontier list looks something like this now. And it completes the expansion of the node Sibiu, and we need to select the next node for expansion, and the next BFS selects the first node from the frontier list, and hence Oradia will be selected for expansion next. And all this, and one point I like to mention here, if you notice how the nodes are being selected for expansion, as you can see, we complete the expansion of all the nodes in a particular level. So we have completed the expansion of all the 3 nodes in this level. If you call it the second level, if you call it the first level, and if you call it the second level, we have completed the expansion of all the nodes in the second level, and only after that we move to the next level, which is the third level. So this is the characteristics of breadth first search, which was also mentioned in the definition part, where first the root node is expanded, then all the successors of the root node will be expanded first before we go to the next level, and so on. Okay, so now Oradia has been selected for expansion, and from the problem description we see that we have 2 valid actions. One is go to gerund, the other is go to CBU, and the nodes for both this action, gerund is present in the explored set, CBU is also present in the explored set, and hence for this node we will not add any more nodes to the tree, and that would also complete the expansion of this node Oradia. And we need to select the next node for expansion, and from the frontier list we see that at the front of the list we have Lugos, and hence Lugos will be selected for expansion. And for Lugos we have 2 valid actions. One is to go to Timisoara and the other is to go to Mehadia, and Timisoara is already present in the explored set, so only one node will be added, and that is Mehadia. And this node Mehadia will also be added to the frontier list because it is one of the node which has not been explored yet, so it will be added to the frontier list, and that completes the expansion of the node Lugos. And we need to select the next node for expansion, and the first node in the frontier list is Rimniku, and hence this is the node that will be selected for expansion next. And the valid actions for this node are go to CBU, go to PTST, and go to Craiova. And CBU is already present in the explored set, so only 2 more nodes will be added, PTST and Craiova, and these 2 nodes will also be added to the frontier list, as you can see. And that completes the expansion of this node Rimniku, and hence we need to select the next node. BFS selects by taking the first node from the frontier list. It's a FIFO queue, remember it is a FIFO queue, so Fagurus will be selected for expansion next. And for Fagurus we have 2 actions. CBU is already generated, it's already in the explored set, so no node will be added. Bucharest, however, is not present in the frontier list or in the explored set, and hence a node will be added for it, and this node also happens to be our goal state. So every time we generate node, we also check whether it is a goal node or not. So here when we generate the node for Bucharest, we check whether it is a goal node, and we see that yes, it is a goal node. For the previous nodes, when we selected whether they are goal nodes or not, we saw that they are not goal nodes, so we did not stop. However, we have reached one of the goal state, and hence our search process will stop here because we have reached our goal. And now we want to provide what is the solution of the search process. So the problem was to start at Arad and reach Bucharest, and then we tried to find out a different path because nothing in the problem definition tells us which nodes should be selected first. So this is how our search process progressed in a breadth first manner, and finally we reached the goal. So now we need to provide the solution. So to provide the solution, since this is a goal node, we'll start from the goal node and we will go to the parent, and when we go to the parent, the action on this edge. What was the action for this edge? It was go Bucharest. When we perform the action go Bucharest, we reach this node. So this action was go Bucharest. So from Bucharest we reach the parent Figueres, and from Figueres, what is the parent? Parent is Sibiu. So you have to find out what was the action here. This action was go Figueres, and then we have reached Sibiu. So from Sibiu we'll go to its parent. What is its parent? The parent is Arad, and which is also the root node. So we'll stop here. And what is our action here? The action was go to Sibiu, and then now we are at Arad, and this is the root node, so we'll stop here. So the solution now is go Sibiu, go Figueres, and Bucharest, and this sequence of actions will now be returned by the search algorithm as the solution for the problem. So whatever I have explained in this example is captured in this pseudocode, and this pseudocode would be something similar to the graph search algorithm that we have studied in the previous class. So like any search algorithm, this search algorithm also takes as input the problem, and it returns a solution, or if it cannot find a solution, it will return failure. And just like in the graph search, we maintain a list called a frontier, and we maintain an explode set. But how we start is we take the initial state from the problem definition. So from the problem definition we take the initial state and we create a node. So this was the Arad node that we created in our example. So we create a node for Arad. Next step is to check whether that node that we have created is the goal node or not. If it is a goal node, then we'll return the solution here and here itself, and we'll return. In our example, Arad was not the goal state, so we'll not stop here, we'll not return. Instead, we'll go to the next state and we'll create a FIFO queue with this node as its only element. And in our example, if you remember, we created a FIFO queue with Arad as the only element. So we create the frontier list, and then we create an empty explode set list, and then we execute a loop, and this loop will continue executing until the frontier list is empty. The frontier list is empty and we did not find any, when we did not reach the goal, means if the frontier list is empty, we don't have any more nodes that we can expand, and hence it means that we are not able to reach the goal. We are not able to expand any more nodes also, and we have not reached our goal, so it's a failure. So we'll return failure. Otherwise, if the frontier list is not empty, remember we need to select the next node that we need to expand. And how the next node is selected for expansion in case of BFS? We'll take the first element, which is the pop operation. We'll take the first element from the queue by performing a pop, and that will return to us the node that needs to be expanded next. So and the node that we have selected for expansion, we add it to the, we remove it from, so this pop operation will remove it from the frontier list, and we also need to add it to the explode set. So we add it to the explode set here. Remember, when we remove in the example, when we remove a node from the frontier list, we add it to the explode set. So that is what is being done here. And now for each action, where will I get the valid action for a particular state? For a particular state, I'll get the valid action from the problem definitions. So this means we are looking at the problem definition and we are taking all the valid actions for that node. So in case of Arad, what were the valid actions? There are three valid actions. One was go to Jerind, one is go to Timisoara, and the other one is go to Sibiu. So this problem, this part here will return those three actions, and for each of these three actions we'll perform this, we'll execute this code. So this for loop will be executed for 3 times in case of Arad. So first we take gerund, for example, and then we try to execute the action go to gerund, and when we perform the action go to gerund, we will create a new node for gerund, which will be the child node. So we create a node for gerund. So the node for gerund will be created here. Although we don't look into the specifics of this function child node, what this child node will do is it will create a new node. In our example, for example, we'll create a node for gerund. Next, we need to check whether this new child that we have created is the goal state. First, we check whether it is in the explode set or the frontier list. Remember, the newly generated node, if it is already present in the explode set or in the frontier list, we don't have to add it to the tree. So that's what we are doing here. We are checking whether the new node is in the explode set or in the frontier. If it is not there, we check whether this child node is the goal state or not. So in case of gerund, it is not the goal state, so we will not return the solution. And instead, what we will do, we will add the node gerund into the frontier list. And then we will go back to the for loop and we'll perform the action for go Timisoara. So for Timisoara, we'll create a new node. We'll check whether the Timisoara is present in the explode set or in the frontier list. It's not present, so we'll check whether Timisoara is the goal state. No, it is not the goal state, so we'll add it to the frontier list. Then we go to CBU, the third action for our RR node, and for CBU we'll create a node. We'll check whether that node, newly created node, is already present in the explode set or in the frontier list. If it is not present, we will check whether CBU is the goal state. It is not the goal state, so I will add it to the frontier list. So CBU will be added to the frontier list. So like this it will continue till for Figueres, when we take the action go to Bucharest, so we'll create a node for Bucharest. Bucharest is not present in the explode or frontier list, and then we check whether Bucharest is our goal state. Yes, it's the goal state. So at that point we'll return the solution. And what is the solution? Solution will be the sequence of actions. So how will you find the solution? The sequence of actions. From the goal state we'll go to its parent, and like that we'll go to the next parent, continue till up to the node, and the edges on that path will give us the sequence of actions that needs to be done to achieve the goal for the given problem. So I hope you have understood this BFS algorithm. This is all that I had for today's class. In next class we will try to see how to evaluate the BFS algorithm in terms of its optimality, its completeness, the time complexity, and the space complexity. So there are different criteria to evaluate the performance of algorithm, and we will look at those performance measure for our BFS algorithm in the next class before we move on to the other uninformed search algorithms. So I will like to end here for today. We'll meet in the next class. Bye.